Jeff.
Hey, Alan, happy Wednesday. It is my favorite type of Wednesday because it is Project Wednesday. How are you doing, sir?
I'm great.
You're not in Tajikistan any longer.
I'm not in Tajikistan, and I'm back into the groove of overworked and not enough time and all that. But I'm here, ready.
That's right. Well, I got to tell you real quick. I had an Uber ride in Chicago, and talking to my Uber driver because you know me, I'm the guy that talks to the Uber drivers, and he said he was from Tajik. And I said, I'm sorry. He said he was Tajik. I said, hey, you're from Tajikistan. That's great. And he looked at me funny. He said, I've been driving for a year and a half. No one knows where Tajikistan is. I said, I can tell you one better. I said, I know about the Monday market.
Yeah.
And he looked at me funny, and I got to tell the story of your daughter and your son-in-law, and also my friend Ryan Haas's daughter. So anyway, all we should probably say, but let's get started. Welcome, everybody. I think we actually set a record today for registrations. We had over 400 fresh registrants for today's live demo, and we are talking about information management in the post-Pi era. We've got our friends from Software Toolbox, Flow Software, and possibly Ken from Canary.
I'm here. I got a new camera, and it doesn't want to cooperate. Hey, I'm back.
There we go. And
it'll be fun.
Maybe that's our technical hurdle for the day, Ken's camera. Here's hoping. But no, that's our topic today is information management in the post-Pi era. To our panel, welcome. Thank you for being here. You're all taking on a 2-week live build that's going to be pretty immense in the scope. Appreciate your, I don't know, bravery, courage.
Yeah, first time doing a multi-week build.
Scheduled, like right on purpose.
Yeah, I mean, we're planning it.
Yeah, might be 3 weeks. We'll see. And I'm just prepared that we're going to have some type of a emoji or something for Ken, an avatar for Ken. Well, hey, let's jump into it, and we'll sprinkle in some dad jokes as we go when it's appropriate. But just to kick it off, before we went live, David gave me a gem of a dad joke, and he doesn't want to share it, but I'm going to. On David's behalf, live straight from Johannesburg, South Africa, via McLean, Virginia. Did you know, Alan, they have developed a new type of coffin?
I did not.
All glass. No more wood, no more wood byproduct, just all glass coffins. Will it be successful? Remains to be seen. David, that was a solid goal.
It's interesting because I got a call literally last night from my sister because her daughter swallowed a bunch of coins.
Ugh.
And I said, "Wow, how's she doing?" And she said, "Nah, no change yet."
I thought it was interesting, Alan, I knew you are quite the world traveler now, and you get out of California once in a while. And I actually had a friend that just recently moved to Switzerland, and I got in touch with him, and I was asking him, what are the pros, what are the cons? You always like to interrogate someone that moves, halfway across the world. He says, well, all I can say is the flag's a big plus.
Yeah. It's true.
That's
it is a big plus.
All right, here we go. Getting into it, and to our audience, you've been on a few webinars before. You know how to use the Q&A and the comments. Please do so. We are going to take questions throughout. If you type in a question and you don't hear us get to it right away, we've just flagged it for later, or it was just a bad question. So, try it anyway. Post-Pi era information management is our conversation today, and let's just go ahead real quick and talk about the statement of the post-Pi era. I've had some questions in the last couple of weeks about what do we mean by that. If you're not aware, it's been almost 4 years since Pi software Pi product by Microsoft was acquired by AVEVA, and there has been a lot of turmoil in the market since that happened, a lot of unknowns, and it's definitely become evident of which direction AVEVA is taking that product. There's been a lot of fallout as a result. And so folks that were long time Pi enthusiasts started looking at other options. It's no longer what the industry might have called 15 years ago the standard. And because of that, the post-Pi era, we need to talk about how we're going to manage data and information inside of manufacturing. And we want to put forth a solution that is, well, let's talk about it. Let's look at our actual business problem. Alan, take us through it, if you would.
All right. So obviously what we're going to be doing is collecting, not just time series data, but we're going to be collecting relevant data, adding to operational context and that's necessary. And the requirements that we have are, right. Well, I'm sorry. The problem that we've had specifically in the realm of not just Pi, but with other industries or vendors that are locking you into that kind of their model. They can do everything for you, but you got to do it through them. So when you get there in that specialized kind of market, you start to have a problem getting talent, right? You're going to go get a person who's going to come in and help you. You're going to pay a premium because they're the specialist, right? And it's specific to their product. Licensing, I can say for myself that this was really the thing that moved me off of using Pi back when I was at Air Energy, and then interoperability, right? You're locked in. If you want to do digital transformation, you're going to do it through them and their way, and then sacrificing security. I mean, Jeff, you took a poll, right? How many users are still using DCOM? What was it? What was the percent?
Oh my gosh. So we did a LinkedIn poll, said, hey, manufacturers, how many of you are still logging data using OPC DA, right? I'll ask the audience, what do you think the percentage was? Drop it into the comments. I'll reveal it later on. How about that? A little cliffhanger.
Yeah. And so
let's just say it was not zero.
Yeah, it's not zero. And look, 10 years ago, we were on this big push of we got to get out of DCOM settings. We got to get out of that that environment of anonymous users being allowed to move, vertically or horizontally across your infrastructure. So that's the problem that we're dealing with. How are we going to solve it, Jeff?
That's right. So, and that is where our team comes into play. So our proposed solution today is really all about bringing together multiple solutions, multiple vendors that are focused on interoperability, performance, and fair business models. And listen, it's important to our audience. To understand, we're not saying, well, we just have to meet these requirements that Pi offers. We're actually looking to increase functionality. So how do we treat Pi as the standard and then actually build something better? And that's what we're working towards. Getting started and looking at what today's kind of scenario is, we are honoring our Canadian men and women in the community, and we are building a maple syrup factory. That's right, Banff Maple Reserve, the finest maple syrup that AI can generate. And our label and our product shot was courtesy of Midjourney, and we had a whole lot of fun getting there. I think at one point we had Mounties riding mooses, throwing maple syrup at lumberjacks, but that is our finished product, and that's what we're manufacturing in our plant. We're going to break this out across 2 weeks. So week 1, today, focusing on data connectivity, data logging, and the beginning of data modeling. Next week, same time on Wednesday, you do need to register for that specific event. There's not a carryover. registration. I'll drop that in the link just now. But next week will be focused on asset-based calculations, data cleansing, event context, KPI aggregation, dashboards, automated data streams, and API access. If for some reason we cannot complete all of that list in our 90 minutes, we will go ahead and do an extension, and we'll either film that and drop it onto the channel, or we'll just run another Wednesday. Always a recording available of all of these sessions. Just remember, you can grab them from our YouTube channel. Okay, so let's get moving. Let's take us through our architecture. We're going to start on the data connectivity side, far left of the architecture. So we're going to address legacy equipment, DCS systems, and some of the weird one-off types of things that typically you would have looked at Pi to use, because that was really the only way at the time, 15 years ago, maybe 20 years ago, to do that type of logging. So how do I bring in flat files? How do I scrape websites for data? How do I even connect to some legacy PLCs or DCSs? Once we're connected to those different sources, then it's all about getting that data into standard, open, accessible protocols inside of our industry. So exposing things into as OPC, UA clients or server, getting it to an MQTT broker. From there, we can start to historize, log that data. We're going to be using Canary to do that, and we're going to move that data securely to the archive. On top of that archive today, we're going to talk about how to model that data, and we'll demonstrate that in both Canary as well as inside of Flow. That's where we'll stop for this week. Did I miss anything, panel?
Nope.
Okay. All right. So that means it's time to kick off the demo. David, would you walk us through, please, what you're going to be using, and walk us through all of the different things that you could be connecting to, please?
Absolutely. Thank you, everyone, and very nice being back on Integrate Live. I really appreciate the opportunity. So as per your architecture or your flow diagram that you've shown in the previous slide, we're going to focus here on the collecting side. Now, I'm not going to talk today about the standard things, because I mean, we all know there's top servers and kepware and hardware solutions, etc., that can communicate to PLCs, etc., etc. We're going to address these little anomalies, for that matter, things that's not out of the box, where there's potentially a requirement to bring elements into a bigger system for data logging, for example. So we're going to firstly look at OPC Router today, which is a product that allows us to pretty much connect anything to anything and do things like information transformations, connectivity, etc., etc. So we're going to go through an example where we're going to take, for example, a CSV file, a typical type flat file, and look inside that CSV file, and I'll go through that when we build the demo, and expose that information in the OPC UA tag format. The second component, we're going to look at Data Hub, and using Data Hub to become a little bit of a tool to say, because there's still so many people out there, and the example we're using, for example, for the maple syrup factory, is that there's power pricing that literally is published on some sort of a website in Canada. And if you're an operator or a manufacturer, you would like to have what is that history of that power pricing, and obviously make decisions off that. But unfortunately, there's no API to go fetch it like in the modern days. We need to go scrape a website. So I'm going to show you how we do that very quickly. There's so many other opportunities, obviously, that things like Router and Data Hub can actually present, and I might touch on that as we go through this. But without further ado, I'd like to actually jump into screen sharing and say, how do we address this whole CSV to OPC UA component, if you're cool with that, Jeff?
Yeah, let's do it.
Perfect. So let me just try and get my screen up and running. Don't show the tips again. And I will go there. So I'm going to apologize. I'm going to face this way to this one of the 17 screens I have here. And you're going to see that beautiful side of my face. So basically what we have here is OPC Router. Now let me just put a little bit more context in terms of what it is I'm going to try and show everyone. So, and this is based on true reality that's out there. We've got numerous customers that says, look, we've got this new laboratory system that we bought. And you would think it's a great laboratory system. It's got the capability to integrate and have an API or have a built-in OPC UA server. And then you realize after the fact that, actually, the only way that this thing outputs information is in a very, very simplistic CSV file, something like this. So I've just built something here and say, look, this lab system, every time it does a analysis of a batch or a bottle or whatever it might be from maple syrup, it kicks out a few things. First of all, it has a sample time, it has the product, it has maybe some analysis, and it has some sort of a very objective quality. And that's it. Now, how do because I'd like to obviously keep historical data in terms of this analysis that's been done, but specifically the values related to sugar percentage and salt percentage. Don't ask me why there's salt in maple syrup. I just couldn't come up with another ingredient. So we would like to have history, and obviously based on that, you can apply things like statistical process control, you can report on that, etc., etc. So in order to achieve this, we have this, so I'm going to just say save it, and we're going to do that file later. Let's not even save it. Let's just say cancel. Thank you very much. So what we are going to try and do is to very quickly, and I'm going to show everyone the components of OPC Router to build something like that, to be able to analyze a CSV file or an XML file or an Excel file for that matter, and bring that into an OPC environment. So very, very briefly from an OPC Router perspective, OPC Router, as I said, is this toolbox of a visual way of connecting data sources to each other. To have a source, we call that plugin. So you can kind of say, look, where does my data all come from and potentially go to? So you can see there's a plethora of different opportunities here, from MQTT to all the OPC capabilities, including things like OPC methods and PubSub, which is fairly new, relational databases, other types of databases, time series databases, even the mighty SAP is part of this native connectivity that Router brings out of the box to the table.
Is that
so
certified?
That is a certified connector for SAP. That is indeed correct, Jeff. Good question. So literally what we have on this side is, look, the two things. So first of all, I've set up a little FTP component. So I'm just sharing something. That lab system would typically, in an FTP kind of environment, put the CSV file. So you would literally just create a new FTP object and say, look, where is it? Is it on the network? Is it local on my machine? Is there some security involved? Obviously, I'm not running any security. And I can check the connection and everything says, great stuff. I am connected to this FTP server for that matter. The second component that we obviously need is we need to write this thing out to a OPC tag. So what Router has the capability of is to say, well, I can do everything that happens inside Router can be served out as what they call global variables. So literally by just saying, look, Router, act as your own OPC server and just tick the global variables box, I can then serve out everything that I read. Also, just to add to this, if OPC is not your chosen way of actually communicating data, unless, for example, you wanted this data not only going to OPC, but also potentially to an MQTT broker, either on-premise or in the cloud, I can just go add in a little MQTT component. There's already a Hive configured, and I can in parallel just pass these things to a broker also for other consumption, for integration into your unified namespace, etc., etc. And Canary can also obviously consume from an MQTT perspective. So that's the components in terms of the plugins we require. The second part is obviously where we say, well, what is it that we're trying to do? So you can see here, let me just minimize it at the bottom. We've got this concept of, first of all, the tools and the ETL objects, which ranges from JSON objects where I read JSON payloads, transform JSON payloads, write JSON payloads, to the fact that I can connect to these data sources and do things with it. And I'll show you what that means. And then the last component says, well, how do we want to fire this thing? Now, in this case, we don't want to go read every 10 seconds for a CSV file. We literally want to monitor a FTP folder. And only if there's a new file that appears in that folder, we'd like to then say, well, kick off this little transformative workflow, read it, and transform it into OPC. So I've cheated a little bit just to save some time. We've created a flow or a connection as such, and it creates it uses this little blocks, is what we said. Now, everything we do here, when I do that, it's all drag and drop in this web type environment. So I'm going to take you through the block first, and then I'm going to go into a few of the configuration settings. So let's worry about the.
Is
Yes,
anybody else getting like a Node-RED feel from this?
Yes, but the thing is, this is a little bit, look, first of all, there's an incredible templating capability here, which is superior bar none in my own opinion. And then secondly, this is built to understand the OT environment, but also the IT environment, and not only the IT environment. And I think that's what makes OPC Router quite unique.
Yeah, so built for engineers,
yeah,
rather than for IT teams.
And easy to use. That's the whole thing, like I'll show you just now. So we literally have a little object that we've said, look, we take one of the network file read objects, we configure this object. Now, remember I said, look, we want to monitor a folder. Well, we literally select the connection. We literally tell this thing, go look in that file, and in that folder, look for that file called lab data CSV, and then read the text. Then we drag something into this little CSV object that we've kind of just moved over. So I'm going to just delete that because I've pre-configured it already. And we say, well, within the CSV object, and remember, this could be Excel, this could be XML, they all have different objects. We can then say, look, there's the simplistic things of what am I using for a separator? Do I read the first value, or do I read a continuous effort for that matter? Is there a header? Is there no header? If there's a header, where does the header start? What is my date time format? What decimal do I use? And then the last thing is, as you remember what we've just seen from the CSV file, is to kind of say there's a few parameters that we are after. So the parameters are, in actual fact, product, sugar, salt, product quality, sample time for that matter. I'm going to try and close this thing again. So it is probably going to mess me around now, but it's not the end of the world. We'll get that going. And I literally just define these parameters. And lastly, I write them to variables. So I create either global or local variables within OPC Router, and I push it out to an OPC data access object saying, write to your own server, and there's the addresses. So that's as easy as that. And then literally once I've done that, I can say, and by the way, just to add again, if I wanted to in parallel publish this to an MQTT broker, I could literally just say, look, there's the broker, and take whatever value it is and define it in a payload and a topic for that matter. But once I've done this, and I say productive, this thing now sits and it says, look, I am now waiting. So you can see in the last couple of minutes, absolutely nothing has happened. So what I wanted to do quickly is to now say, let's try and see if we can get an updated value. So what I am going to be very, because you know, Murphy, when you do these kind of things, and that's not going to allow, oh, it does allow me to delete. So I'm going to say copy. I'm going to just, as if I'm the lab system, I'm going to create a new machine and a new record from this. So we're going to say, look, the sample time is the 29th. We're going to call it maple AAA. We'll do the sugar, something like that, and the salt is 1%, and this is good enough. A really subjective kind of thing, and there it is. So now the analysis has happened, and if I literally close this now, and the lab machine would put that into this new folder, which is the folder that we monitor inside a router environment. So if I do that, it sucks it up, and by hook or by crook, I see a little dot appears there, which means it has fired. And if I look at that now, I can see, well, there's the Maple AAA with the 89.1 and the good enough. I've taken the CSV, I've split it out in its specific components, I've written it to variables, and I've written those variables to the environment. And just to prove to you, I've got a little UA expert client here. There, it's just updated in terms of 1124. There is the values that we've just seen. Now, what I can do, obviously, is I don't like to do this hand by hand. I could also create a template of this if I had multiple similar systems, which allows you from an engineering efficiency, etc. So that's how easy something like a flat file can be converted in order to get that into Canary as a process historian.
David, do we have time for a couple questions that have come through?
Absolutely.
Okay. I just want to lead, maybe, if you don't mind, with my own. And this is as much to the audience. So any of our audience members that have experience of doing flat file ingestion using Pi, I would love it if you would just comment on what you've just seen versus the effort that you might have to go through on a Pi system to do something similar? That would be super helpful, I think, for others to know from your experience.
Absolutely.
David, can you speak to what the amount of time that you actually put into building out what we're seeing? Is this a 30-minute effort? Is it a 3-hour effort, 3 days?
I do this so often, so that's unfair. This should, if it's more than a 10-minute effort, you are doing something wrong.
Okay.
That's having a cup of coffee in between. So it's truly simple.
All right. And there was a question of, is OPC router actually built on Node-RED? I'm assuming no.
No, not at all.
Yeah. How long has the product been in the market? What's the support look like?
So we, as from a software toolbox point of view, we are the distributor and the support element from a North American point of view. It's been around for a couple of years. We're sitting on version 5.2 at the moment, so you can imagine it's quite mature. The web interface is the latest addition to version 5, and it's just growing. I mean, and we've got a great let's call it a relationship with the development team. So new features that clients want, etc., actually gets added in quite quickly if it makes sense, which helps us to kind of keep the product development dynamic yet still within bounds.
Okay. I've got a good question from Mateo up on screen.
So is the licensing of the outbounding service UA in this example included? So the licensing can be, I'll just talk very quickly about the licensing, and I think towards the end of this episode, we'll get into licensing again. So there's a perpetual component which allows you to pick what you need. So if you only need an OPC UA client, for example, you just buy the client license. If you need only CSV, there's a base license that includes a few things, pretty much like the JSON. So everything that sits here is kind of included in the base license, and then you license your functionality. So if you wanted Kafka, you add Kafka. There's a subscription model also that allows you to, let's call it, clump a few or bundle a few of these elements together and get away with more bang for your buck. So
the spoiler, let's just let everybody know in advance, the perpetual license for this thing, it's sub $2,000 based on what you've done. This is not this is
not super. And then another thing also, maybe just as I said, this is built from a OT perspective, so it supports redundancy out of the box. Hot standby, automatic failover. It supports stored forward out of the box, so that if the destination, like an MQTT broker, is potentially offline, it'll just store the data locally until that broker is available again and just publish it up. So these are the OT features that is built in. Audit trail capability coming soon. Good question.
Always.
That's our friends in the pharma industry are asking that, and there's work being done, heavy work being done.
And versioning as well?
The versioning will be part of that functionality, correct.
Okay. Nice comment from Jarko. I apologize if I didn't pronounce your name properly.
And just to add to that, so what a lot of people do is, like you say, this traditional IoT that typically writes through a gateway to a cloud and then there's an API. I can take this REST API object, and so there's a REST client object, but it can also be a REST endpoint on its own. And we're doing some really fancy stuff with that for some clients. Convert that to MQTT or OPC UA or send it to a database. So that creates a lot of flexibility. Yes. So
there was
really,
a question
really
about
question.
SAP for HANA.
Thank you, Doc, or thank you, Alan.
HANA is included, absolutely. So it's licensed on its own, but HANA is part of the relational database component.
All right.
And I'd love to, Christopher has got a good question there, and then we'll move on. From a performance benchmark, there's nothing benchmarked, but reach out to me and I will share with you a little bit about some applications we have. I've not seen the end of this yet in terms of hitting the limit, which we're doing a lot of transfers quite quickly.
Perfect. And thank you, Luke, who took some time to share his experience on the Pi side using the UFL interface on a few sites he's worked on. He's able to work through this typically in about 4+ hours. and then he just does a copy and paste install. So shorter time, obviously, it seems, but actually, Luke, thank you for sharing your experience. I would have thought a full day worth of building that out for the first time on the Pi side. So it sounds like about half a day if you know what you're doing.
That's really good. Thank you.
Yeah.
No, we've answered a whole lot of questions now, so I'm going to just quickly skim through the next one, and then I'm going to let the show go on. So we are done with Router now. I'm not going to worry too much about Router anymore. The second, if you can recall, the second example was the fact that we have this website in Canada, which is a real website, by the way, the Alberta Electric System Operator Company, and they publish every hour, and sometimes more than an hour, what the price is. And by the way, it is super cheap now. It's 54, I think it's Canadian dollars per megawatt hour, which is cheap because so obviously there's no demand at the moment. Look at what it was at 9:15 this morning, Canada time. $9, $16, $20, $27. So we want to obviously log that data in order to make sure that we can run and it makes sense that we do produce, or is it cheaper to actually switch off the plant? How do we get that data into a format that I can actually send it to a process historian? So we have another little tool called OPC, Cogent Data Hub. And Cogent Data Hub has got amazing features, but I'm not going to cover all of them. I mean, the reality is Cogent Data Hub can connect to DA sources. So just to allude what Alan has spoken about a bit earlier, if you have a DCS system that potentially only has a DA server, that's not secure. We have the challenges with DCOM, etc. What Data Hub can allow you to do, or can enable you to do, is actually just wrap UA around that DA server. So we add some sort of sense of security with certificate management, etc., for the clients to connect. Doesn't solve the DA problem, but at least solves the connectivity problem. So we can convert DA to UA, we can convert UA to DA, we can tunnel that through a encrypted tunnel protocol, etc. But that's not the discussion of today. What we're going to do is kind of say, okay, so we have a very powerful scripting environment also. Now, don't have a fright. We've written a little script, but it's also on our website. So you can just take this and go, do it yourself. But we literally are just doing a bit of a substring function on a website. Parse it out, do it whenever it changes, check for a change, do it whenever it changes. And once we do that, we serve that out as a tag or a point called price. And what did I just say is the price? If we look there, 54 cents. And if I go back to my data viewer, 54 cents. So once I've done Router for Cogent Data Hub for that matter, I just say, look, serve it out in a specific environment. And if I go to UA Expert and I look at my price, I've got 54 cents. And that's it. So it is so easy. A little bit of scripting, no lies about that. But what we also do, for example, I mean, another use case of Data Hub, which is really strong, is, for example, handling OPC UA arrays. Now, you cannot store an array in a process historian, but we can split that array in its different points, which we use Data Hub to do. And then we just store the different points inside the process historian. So there's also sample scripting on our website in terms of that. That gives you the capability, or just a little bit of an overview of capability of what Data Hub can bring to the party in terms of that.
Now, there's a lot more, though, that I see over on that outside column. And one of those right there at the top is OPC DA converting to UA, which is a great segue to say we had a lot of very accurate guesses on the percentage of DA use in our comments. I will say that our closest, we have Nate and Alex both logged in at 72%. Literally 69% was the answer that I had on my poll. I'm going to drop my email in the comments. Nate, Alex, send me an email. I'm shipping you some Integrate Live something, laptop stickers. I don't know. See what we've got sitting around. Maybe a polo if I've got a spare one sitting around with tags. Great guess, guys. Now, the follow-up poll is what percentage of CSIOs and CIOs have any awareness of the amount of OPC DA currently within the factory? I have a feeling that is a much smaller number. David, what can you do for a DA conversion?
Look, it's exactly the same price as what we're going to touch a little bit later, but because we have what we call the IoT gateway component, which literally is the DA to UA, UA to DA. The scripting is part of it, etc. So, I mean, it's also sub $1,400 or something like that for a single node. So it's nothing for peace of mind.
And anything else we've done? Was it router or was it Data Hub that on previous Integrate Lives we were doing labels and barcode scanners?
That was the another product that we have in our stable called OmniServer.
Okay.
That allows you to take custom protocols, and that's maybe also applicable if you have a weigh scale sitting on a plant floor or production line that doesn't speak Modbus, it speaks some sort of a custom protocol. We can use something like OmniServer to define the protocol, design the protocol, and it's all a visual format, and then basically run it, and it serves whatever it reads from a scale or a barcode scanner or a printer as OPC tags, which you can integrate into the rest of your system.
Okay. Everybody, I've pinned David's contact information in the comments. So Software Toolbox, we refer to them as data plumbers. They are experts. They've got a team on hand that you can call them on the number on the website and have a conversation this afternoon about, hey, here's what I'm dealing with. Here's what I'm trying to do with it. They'll walk you through your options and solutions. Great men and women behind the products.
Hey, Jeff, can you share my video?
Huh.
Let me stop that.
Yeah, maybe. You gotta present it to me, and then I'll gladly do it.
No, just my video, my whiteboard.
Oh,
so one of the things that
Ooh,
you know,
maybe. Hold
my
on.
role at 3M is I'm the director of OT security, and one of the things that I'm trying to solve in that is how do you manage your data in a, you know, where you're talking about moving from the Purdue model, which is a good model, defense in depth, all those things, but then moving into a zero trust model. And so one of the things that I'm working through is really thinking through how do I start to restrict my ingress and egress into my control system, right? Well, Data Hub is really what we're looking at, right? So we're looking at Data Hub in level 3 with OPC router. You start to think about, I can now start to connect to everything in my control system. And then I can change the protocol moving from my control system into my DMZ. So now if you think about, I have all these different protocols down in level 3, I can collect all that, change the protocol, and now I'm transversing out in a pub sub manner up to a Data Hub that sits in my DMZ. Now I have Data Hub in my DMZ that has SAP. It has opportunity to get the data from level 4 back down into my DMZ. Again, I can change the protocol, and I start to restrict the access and the number of firewall rules I have to have that transverse my levels. So just another is, if you're starting to think about the opportunities of what you could do with Data Hub and OPC router, security is a huge opportunity here.
Yeah, awesome. Thank you, Alan. Nice little ad hoc diagram on the whiteboard. You didn't draw that while David was going, did you?
No, I've been working on that for a while now.
That would have been impressive. Where do we leave off? So we've just covered the first two parts of that architecture. Let's talk about the existing legacy hardware. If you've been with Integrate Live for any period of time, you've probably seen us do a demo using Opto's products, their Groove line, that's their Epic, and their Rio, both part of the Groove line. This is a great way to connect to your legacy hardware and to expose it using the built-in technology that the Groove offers. That could be Ignition Edge, or it could be the Groove's ability to function as a OPC UA server, or to publish out as a Sparkplug MQTT protocol. So you can connect to existing PLCs and expose them to an MQTT broker. You could connect directly to remote I/O. you could drop a Groove Rio EMU, the energy monitoring unit, somewhere in the plant and start exposing the amount of energy that your equipment's consuming and feed that into an MQTT broker or into an ignition ecosystem, or expose it using an OPC UA server that is on board the Groove products. So just another way to say, hey, here's some old stuff in my factory. It's working great. I don't need to replace it just for a digital transformation, but I do want to expose the data that it has connected to it into this ecosystem that we're building. So I would encourage you to take a look at Opto's products if you have that scenario. We've done videos before. You can find them in the library on our YouTube channel. We don't need to re-demonstrate that, which we've already done once or twice before. Okay, so let's take a look at where we're at. We've covered really how we're going to go.
I don't want to get off of, I don't want to leave David until he explains to us the poll that he's recently taken.
Oh, he had a poll as well?
He did.
Yeah. So because in my home country, it's elections today, so this is a really suitable comment. So the other day, I actually took a poll, and 100% of the people in the tent were really angry to me.
The delivery, perfect.
It's because I wrote it down, Alan. Thank you so much.
Well done. Well done. All right, let's move forward. We've connected to everything on the left. We've now got it ready to move into our logging technology, which in this case is the Canary sender. Ken, can you tell us a little bit about the sender? How does it work? What's the technology behind it? Give us the rundown, if you would, please.
Sure. So of course, the sender is not connecting directly to the data. We have our OPC collector in the middle, that David will show here in a little bit. But our sender is our way of transporting data over the wire to wherever the historian or historians may reside. So sender is the first part of our store and forward technology. That transmission is secure, use a TLS. It's port-to-port access, so it's very simple to get data from one machine, one environment to another. Works great getting data through proxy layers. If you're not doing an architecture similar to what Alan just presented, it's a way to push data from 3 through a DMZ, a 3.5 layer. If you're doing Purdue model, up to a corporate or a cloud historian. As I said, it's the first part of our store and forward. So all buffering, we actually write everything to disk. So it's a pretty hardened service. It's pretty resilient to minimize any potential for data loss. And our sender is also where we can do duplexing, triplexing of the data streams. So if you have a site historian, corporate historian, QA, dev, cloud historian, however many destinations you need to send your data stream, sender actually takes care of that. So if your site historian's up and something's going on with your corporate historian, or the network to corporate is down, you'll continue to receive data at your site historian, and only the corporate stream will be buffering. And then once that connection's restored, then that buffer will, of course, flush as quickly as it can to get the corporate historian caught up. So we use the concept of duplexing or triplexing quite often to ensure that all historians are receiving the exact same data being collected from whatever the data source may be. So
I can give some context around my experience specifically with what Ken's talking about. So when we had at Era, when we had Pi, every month we would do a patch night, right? And so when we would do a patch night, we had the Pi team would be up all night. And what they would be doing is they would be trying to sequence the system back up. And so if you're familiar with Pi and OPC UA, you understand that you can't just fire computers up and everything links back up. You literally have to go through a process, and you gotta wait for it, and you gotta start the next one. And it would take all night, and they would be up all night. When we moved to Canary, the architecture that we built was on every ignition server in level 3, we installed the Canary sender, and so we literally would publish from ignition locally to the sender, and then we would move from the sender to our DMZ, and we would receive in the DMZ, and then we would send it from that up to our level 4. And what was fascinating to me about that was, now we had a ignition site license, so it became very simple for us to put the distributor module on every single server, and we had a lot of kind of freedom to how we had 160 gateways, ignition gateways. So, but because of the Canary model licensing, we were able to put the sender on every single ignition gateway, and we literally went from having to maintain, our enterprise historian, with a team of 5 FTEs and some contract workers, down to literally now the system is, we have 1 FTE and 1 contractor for the whole historian. And a lot of that has to do with the resiliency of, now patch night, reboot the machine. We don't care. It comes up, everything works. In the morning, the guys will either in the morning or when they get the email at 8 o'clock at night, they go check to make sure it's all up. It's all good. And so the ability to have that, the resiliency of that, not just the, hey, yeah, I'm passing my data from my level 3 to level 3.5 to level 4, but the consistency of it was phenomenal. And to this day, still. So
Thanks for that, Alan.
you, Ken, for an incredible, successful experience that we had.
Appreciate that. Yeah, and I guess one thing that he mentioned there that I forgot to mention, because I'm not a sales guy, but the licensing concerns. Our collectors are not licensed, so Alan was able to install literally 160 collectors all over the place, completely distributed, with no impact on licensing or cost. And those of you that have worked with Pi, I think you'll agree that that's a drastically different model than what they operate under, where interfaces are not free, and so you start making architecture decisions because of cost avoidance.
Yes.
And Ken, the other thing maybe you'll touch on, you'll touch on probably later on when you talk about the actual historian, but just to set a pin on this, the concept of being able to take a unique logging session and keep that segregated the whole way into the historian, as we talk about data sets later on, maybe just to revisit, okay? It makes management, I think, so much cleaner. Can we do a demonstration of the store and forward? David, you were connected at one point, I think, to Canary's dash tool.
I can quickly do a screen share, and then
while you do that, you got a couple questions, and maybe address.
So to get data through the DMZ, when I said we operate kind of in a proxy manner, currently that would require a pair, our sender receiver, to both be installed on that level 3.5 server. So the receiver is receiving from the level 3, and then turns around, hands that off to a local sender, which then pushes it off to level 4 servers. So super lightweight install, but it does require, of course, Canary services on that machine in the middle. Our redundancy is different than Pi. We certainly have many customers that run redundant collectors, especially if you have redundant OPC servers, or even if you have one OPC server or one data source, they may run 2 collectors as well. We call that kind of our poor man's redundancy, where we're sending two identical streams of data to the historian, and the historian sorts it out. It's basically first in wins. And then we do have customers that have done more complex things, where you're doing some sort of failover to allow the data to be collected at multiple sources, but persisted in the historian to a single tag, single data set.
Yeah, and at Era, what we did was we just leveraged the storm forward. So we had a single sender going to a receiver, then the sender going to my level 4 receiver, and if we made sure that the system in level 4 was my primary ID, and if I lost connection to that primary, it would storm forward. When it came back, everything came back.
David, screen share
Let's
dropped
do
off.
that quickly. Yeah, yeah. So I thought they wanted to look at your beautiful face.
Thanks, David.
So we have got, just from a context point of view, this is locally on my machine. So this could be level 2, it could be level 3. In my opinion, this is level 2. So I've just got a sender installed here. So literally, I have an OPC collector. So and again, I want to show I'm collecting from Data Hub, I'm collecting from router. I can go configure it, so I can quickly add in another tag. And I mean, the beauty is to get the tag in shouldn't take another 10 days. In the group that I've created, I can literally click this beautiful button called Browse, and I can go and find whatever it is that I want, my salt and my sugar, for example, and say, well, please add them and apply them. And all of a sudden, that is now in the Canary database, getting logged. So we are looking at price, we're looking at production for that matter. So what we wanted to illustrate quickly while Ken messes around with me. Yes.
Just quickly. Again, in the Integrate Live library, just from last month's episode, we actually did a feature on being able to use Canary to log not just to a tag, but actually to a directory or to a folder-based path, so that as tags come into the ecosystem of that OPC server, Canary will automatically start logging those tags based on the folder path. So you could log just off the very top of that path, and every tag that shows up will start getting logged automatically. You can check that out again in the library on YouTube. Sorry, continue. So we're looking at Axiom, the trending tool.
That's correct. So I just wanted to because Ken is now going to, this is the sender, and then Ken can do the talking. And yeah, we're looking at the blue value, which is kind of the frequently changed production figure that I'm running. And the idea is well, it looks like Ken's already stopped it, because I can see my buffer is, my local store forward is actually starting to add up. And if I just move to the right a little bit, give it another 5 seconds, talk about the weather, you should see that, look, we've got 8, 9, 10, let's wait till 10.
And so what's happening is Ken has stopped the receiver service on the historian side, which means the sender is sitting there trying to find the receiver on the other end and saying, no, it's no longer available. So because the historian is no longer available, network's gone down, the sender is buffering automatically local to disk on David's side. Now, Ken has now already restored the network, and the buffer automatically cleared, and the data that was not getting into the trending tool now is automatically backfilled into the client as well.
Right.
Yeah, that's what
the question we get quite often is how much data can we hold in the buffer, and we've had people that obviously weren't monitoring their system and literally have had a month's worth of data fill up in their buffer. And so the answer is, how much disk space do you have?
And how much do you allocate?
Yeah. And so, as I said, we do buffer to disk. It is a compressed binary format, so we're not just writing out, a bunch of ASCII tag names and, the full timestamps, so it is an intelligent buffer as far as being pretty efficient as far as how much we can, compact and write to disk. And I've literally seen a buffer over 100 billion values sitting there. So took a little bit to flush that out, but
100 billion or million?
That was a B, as in billion. I've seen 100 billion values. It was about, I think 100 billion values was somewhere around 10 gigabytes of space. So.
Oh my goodness. All right.
Well, it's pretty resilient.
That's great. That's great. Okay, let's
Also, don't
let's
forget to allocate how much memory you're going to allow your historian to use.
yeah.
Very
That's right.
important.
Question from Mateo is, can you change the default file location of the buffer, or is it always going to be in the program data Canary Lab sender buffer folder?
Yeah, so it's always going to be in program data, but you can change the location of program data. So, customers that, know that they have, intermittent connections, maybe the C drive isn't the best place. We want to reserve that for OS potentially. So attach another volume, use it as a data drive, and then move program data to a drive other than C to get additional space.
Great. All right. Hey, Ken, walk us through the historian a bit, if you would. So we've covered on the architecture slide. We're now ready to push data to our actual archive. So hopefully those that are familiar with the Pi system are starting to see, look, the interfaces has been covered. Now we're talking about Pi archive, and we're going to talk really and compare Canary's archive solution, the Canary Historian, to that.
Sure.
Ken, you're going to cover performance, you're going to cover management, you're going to cover scalability and some other things, and then actually show us that layout, correct?
Sure. Yeah. So I'll talk so that I see the talking points, so I don't forget what I'm supposed to say, and then we'll switch over to some screen share. So we've been in the historian business for quite some time. The company was founded in '85, and so we've been doing. Next year will be 40 years for us, and we've been doing historians for most of those years. So we do have a proprietary database. It's custom built for time series performance.
Yeah. When was that created? What year?
The company started in '85. I would say our first historian came a couple years later. We were actually a trending company before we were a historian company. And we found that we were having performance issues trending because we were dependent upon a third-party system to get our data. And so our trends didn't perform very well in MS-DOS, so this was the good old days of, non-visual. And so because of the headaches of trying to trend data, we realized that we needed to have our own database if we wanted to be truly performant. So 86, 87, our historian came out. This is probably the third iteration of it, but this iteration we've been running since actually the early 90s. So this format, this internal structures that we use, the special sauce on how we compress our data and do some run length encoding, all that has been around since the early 90s, and it's been running for about 30 years now. So
can I tell a really kind of neat 30-second origin story?
Sure. Yeah.
I don't think many people would know, and I apologize if I get some of the details wrong. But so Canary's founders, two of the men are brothers, Ed and Gary. And Gary is really the software developer. Ed was working in sales, and Ed was selling super high resolution CVT monitors back in the 80s to very specific manufacturing processes. And so they would spend a ton of money, like $10,000 for this super high res monitor. And then the first thing they would say that Ed would then hear is, my trending tool is not detailed enough to actually take advantage of this high res monitor. And that was the idea that Ed plugged to Gary on the development side, said, hey, can you build a higher resolution trending tool? And then from that, of course, became well, now I need better data because I can actually show a lot more pixels, where before I couldn't on a trend. And now I actually can have better data resolution to support the amount of pixels that I can actually show on my trend. The database needed to be built to power the trending tool, which needed to be built to power Ed's monitor sales. And that's where Canary came from. Okay. Ken,
Yeah.
walk us through the specs.
Sure. So, one thing that we like to tout about the historian is that we have lossless compression. So we have, a really good algorithm to compress, minimize the storage on disk, but still be extremely performant. And we're doing that without sacrificing any of the precision that you hand to us when you're logging data. So, Pi has the ability to be configured to run this way also. Out of the box, they are not. They're historians making decisions on the data arriving, whether or not this data is significant enough to record. And so our historian is actually fairly dumb. It rates everything that it receives. So there's no additional processing at the historian layer. Whatever a collector deems necessary to log, then the historian is going to log those values. And then when it's time to request that data back out, you're going to get the exact timestamps, every timestamp received, every digit of precision that was handed to us is going to be returned to you as well if you're asking for that raw data. And so even by not doing any decisions on the historian to not log data, we can actually log about 1.5 million values per second. That would be on a distributed system with multiple collectors coming in, and we can read data out even faster than we can write it. So it's highly scalable. We say we can run somewhere between 2 to 3 million tags on a server, depending on data resolution. All kind of factors go into how much can you cram on a server. Those are always discussions that we have to have with the customer. But if you have the need to overrun a single server, then we can start kind of clustering databases, database servers, historians, if you exceed that 2 to 3 million point. And then what we do is the next piece that we'll talk about a little later in this episode is our view service. View service can actually pull together multiple historians so that you can have a unified view of all your data, regardless of how it's segmented under the covers.
I'll just throw out another point of context here of when we were considering going with Canary, one of the first things that we did was we brought Canary in-house, had them set up their historian, and we did testing side by side because we had to meet the minimum viable. And so Canary was able to come in and show that they could meet all of our specs that we were currently seeing with our current historian, and and really was able to show a better level of performance for retrieval, storage, compression. It wasn't a fair fight, I'll be honest about that, because we had the Canary engineers sitting there tuning, and we didn't do that on the other side. But the point we were trying to achieve was, can we meet what we're seeing today? And we did much better than that.
Ken, would you be willing to do a screen share and walk us through some of the historian structure, and then also demonstrate the abstraction of tag names in the views component?
Sure.
While you set that up, a question came in from Keith. Keith, I'll address this just a little bit because it's a question that in my Canary background, I used to get a lot. It is so complicated to estimate disk space because just because you're reading doesn't mean there's so many different things that go into that, from the data types to what is the actual change rate. Most data, even though you're reading updates, doesn't actually change every second. But typically, if you're looking at a medium-sized manufacturing facility, so let's just call it 60,000 tags, you're probably going to spec around a 5 terabyte historian database. If you're looking at a massive operation with millions of tags, well, you're going to have tons of storage required. It could be 10 to 20 terabytes. What's important to understand is that Canary works on a delta algorithm. So they're not writing the exact same data point over and over and over again if it hasn't changed. They're keeping track of changes, and they're being very efficient in how they do it. Typically, you're going to see about a 20% efficiency over a Pi archive running the same type of lossless settings.
That was a much better answer than I was going to give. I was just going to say a lot.
And follow-up question, does it do compression, or is every data change stored? It's the answer is yes to both. So it is compressing, meaning it's not interpolating and compressing. It's a lossless compression. It is, instead of, it's the fastest answer is it is finding efficient ways to write the delta of the change rather than writing the entire maybe long tag name and all of the value every single time a tag changes. It's able to reference the tag name on a table. It's able to shorten the amount of data being written because it's only recording the delta rather than the entire value again. And then secondly, if the value is an integer of true, and again, on the next poll, it's true, and on the next poll, it's true, it's not writing true every single time. It is simply extending, hey, I know I've got connection to the point. I have had a true read for the last 5 minutes. I'm extending that value true continually. However, later on, if I query that data, I've got my timestamps available to tell me when true turned to false and false turned to true, or when I lost connectivity. So more questions? Keith, I can tell that you've got some questions. I'm going to connect you directly with Ken.
I was just going to answer his last question there pretty quickly. So as I said, the historian isn't making decisions as to whether or not to write any values it receives. That logic is out at the collector level. So when we're talking to OPC today, that's what deadbanding is for. So if you do have noise, OPC allows you to configure those deadbands to say a value change has to be this significant in order to be passed along, as a change within the data stream. So, those decisions are done, at the edge or wherever data collection is occurring. We're not making those decisions on the back end at the historian.
But as you demonstrate views, you can decide when you're querying the data to ask for it raw, or you could ask for it from aggregations. So you could say for every minute, give me the average or give me the range. I'll take the delta, and you can treat the data differently that way.
Sure. Yeah.
Okay, let's hold questions. Thank you, Keith. Appreciate that. And thanks for the great questions. Lee, we'll come back to you on your question. And Ken.
All right.
3 minutes, and then we got to kick to Lenny to watch the time.
Okay, 3 minutes. Okay, I do talk fast, so here we go. So this is our administrator. We try to have an all-in-one shop for all administration of Canary services. So we won't go over that right now, but I'll jump right into the historian. And you can kind of see, we use our administrator uses a tiled interface. So all these tiles represent what we call a data set. So our archive is not just a large blob of tags. We actually have some level of segmentation, which I spoke about before. That segmentation typically equates to a data source, and that data source would, typically have a one-to-one data set mapping. So Dawood showed some tags that he's logging with his 2 OPC sessions. So here would be his one, BMR interfaces. And then over here is actually the second one, OPCR. So this is one of the servers that we host in the cloud. So we have lots of other data sources coming into it. Our sales guys use this as a resource. So each data set typically will be configured out of the box to create a new file each day. So I can see the days that Dawood has actually been logging data to my system. And then that allows us for having a really self-contained file that can be moved from server to server, or if Canary support has to get involved, sometimes files will be shared with us. Each of these files can stand alone on their own and be put into a data set on another server, and we can see the tag list, we can see the values for that day. And having these individual files really minimizes our risk of data loss if something would happen, where a server suddenly gets powered down and files are open for writing. That's never good when you're talking from a historian standpoint. So this really minimizes our risk of data loss due to disk corruption potentially. Each data set has, of course, all kind of configuration with it. One of the more important ones that I'd like to point out is our data retention policy. So each data set, you can say what the retention period would be for the data. And instead of doing a hard delete, we've actually added options that those files can be detached from the historian and they move to a secondary directory. And then maybe that secondary directory, you take those and move them to some sort of offsite cold storage. So you don't have to have, an ever-growing hard disk array. You can actually utilize some fairly cheap off-site storage potentially. And then if you ever need to bring those files back on, it's super easy to reattach those files and have access to the data that isn't always active within the historian. Okay.
It's always good practice to make sure you tune that file size, depending on what your actual system's doing, right? So if you have a very large system, you may be an hour. Every hour, you may be creating a new file. If you have a very small system, it may be a week. But you need to make sure that you tune that correctly.
Right. Yeah. Yeah. Like I said, by default, out of the box, it's 1 day, but there's internal protections in the historian as far as what we allow a file size to grow to. So if it's not tuned, by adjusting settings just right, the historian will say, all right, that's enough. You've reached 500 megabytes. I'm going to go ahead and just automatically start a new file. And so, what we're trying to do is really control the volume of day, per data set. And so there's various ways to do that. But those file times, that goes into a lot of our, kind of indexing on how quickly we can jump to any point in time to retrieve data then as well. So,
Ken, can you do a brief browse of views and show us just an example of how that gets abstracted from the historian's logging?
Sure. Yeah. I had a lot more prepared, but we're running short on time. So, out of the box, our view service is, the gatekeeper for all data requests. So there's actually no clients that talk directly to the historian. Everything's going to get routed through the view service. Views is where our security resides, and views is also our service that's akin to asset framework. So by default, we have a view of the local historian, which just simply echoes all my data sets, and it's going to echo the tags that have been logged into those data sets. But the power is being able to then transform those and build out models, or what we call virtual views. So virtual views allows us to provide context, add structure to those tags. Those of you that have 70% of you logging OPCDA, those tags probably aren't very descriptive. They're probably quite cryptic potentially. And so through what we call tag properties, we can attach properties to tags. Those properties can then be used as part of context, and be able to build out some really descriptive, nice hierarchies to help present to your end users, an overview of the process. So I have multiple views that I built here. If you connect to live.canarylabs.com, you can actually see these views and interact with the data. So if I would drill in, I could see, that I've created some sort of structure here around some oil and gas data that I have. And if I was to click on this tag and I look at what the historian tag name is, it's actually pretty good here. So views is our akin to AF. It's very similar, but we have a completely different approach on how we get there. So we don't require you to build templates up front and then do all this tag assignment to the templates. We actually take data sources as inputs, and then we discover templates and then allow you to adjust and modify those templates on the back end. So I'll try to keep that brief, and so that we can finish up here with Lenny, I think.
No, that's good, Ken, because you've just basically highlighted a huge point of divergence between the solution we're getting ready to continue to build over today and next Wednesday compared to Pi. So everything in Pi at this point to contextualize and move forward requires really asset framework. And asset framework's foundation says connect all of your other transactional databases to Pi so that you can use the context of your process, the context of your calendar, the context of what's happening in your operation, and filter or organize your time series data by that. Now, the problem with that approach is that I have to make sure then I have Pi everywhere in my organization. What Ken has just said and highlighted is that Canary is saying, we're going to give you an easy way to transform the tags you're logging in Canary and expose them in whatever standard naming function you would like to. And we're going to give you a way to group those tags into assets or into things. And then we're going to expose that via our API. What we're getting ready to now shift and show is how, where you don't have that branch tree view of the model that you might be used to in Pi, we're getting ready to plug Flow on top of Canary and say, you can build that information model here, and you don't have to try to pump a ton of SQL data into a time series platform. In fact, you could use Canary and you could use other historians. You don't have to standardize on a single historian or a single data logging technique or a single SQL technique or a single platform. You could be running multiple platforms across your entire solution. So Lenny, I'm going to ask that we skip over the slide and that we just talk through it directly from your screen share. Is that fair?
That's perfect. Thanks, Jeff. Hi, guys. Just want to say hi. Lenny here from Flow Software. Always great to be part of the Integrate Live community. Ending off the last few minutes that we've got together here, I just want to say one thing. And one thing that we are very passionate at Flow is the whole notion that we don't like duplicating data. We like to get the data from source. So 100%, Jeff, we don't like to see MES potential data or batch data that is transactional data getting converted back into time series data necessarily just to do a calculation. Rather get it from source where it's meant to be to add context to that historical data that's already sitting inside of your historian. So what is the purpose of Flow? Well, we're talking about information management at the end of the day. But Jeff, very quickly, if I can just maybe ask you while I'm getting ready to share, what would you say is the difference between data management and information management?
Fair question. Data management would be really the process and the people involved going from the tag at the PLC to archiving it in the historian, right? It is the focus on how we are collecting and storing data from our operation. Information management starts to bring in the concept of how do we take data and transform it? How do we add context? How do we cleanse it? How do we define and govern our business rules around data and then distribute information that can be acted on across our enterprise? So information management is very large, widespread. Data management is a piece of information management, but information management is not covered by data management.
Correct. Thanks, Jeff. And I think what the Canary team has shown with the approach that, well, them and the data collection part from OPC Router has proven that data management is pretty simple in today's age. The Canary Historian, from a data management perspective, you set it up and you almost kind of forget about it. You don't have to maintain it. The NoSQL approach of how they store on the data size that Alan averted to, if you get that right in the beginning, then it's a pretty much very low administration process from there going on. And now you can more focus on, information. What do I need to deliver to my subject matter experts to actually make their day or their process actually better in running their facilities? So I'm sharing my screen, Jeff. What the viewers or the listeners should see is a blank model within the Flow configuration environment. And I've got currently nothing configured on this. Now, just a little bit of what you see in front of you is on the left-hand side, as you can notice, that this is where we will build a model. Okay, and the model within Flow is exactly this. It's an information model. It's about the KPIs on your assets that you potentially would like to monitor, or the KPI and the assets that you want to monitor. What was my daily production total of maple syrup, as an example? What was the energy that David now scraped from that website? How do I take that energy, convert it to context to the amount of production that I can get like a intensity calculation? All right, so this is what we're going to just focus on a very short little bit of time that we've got left. Now, a very important thing about information management is this concept that Jeff mentioned about governance. All right, so if I've got a process and I've got maybe 2 lines, in our case, we're making maple syrup, I've got 2 evaporators in that process. If I want to compare the KPIs between these 2 processes, I need to make sure that the calculations and everything is done equally in the same way. So governance for us on flow is a very important thing. And I'm going to utilize our template technology to actually go and utilize templates that's already been built for me. Now, I've got nothing in my model here, and this is my typical site instance of how a flow implementation would look. And if I go to my deployment view here, this is just the different components of flow that is deployed and running at a particular time. Now, what I can do from my deployment section here is I can actually go and connect flow to what we call a template server. Now, a template server can be hosted in the same environment. It can be hosted in the cloud, and it can be hosted for your entire organization or potentially just for one site. But I can go and configure this site instance to actually look at this template server. So I'm just going to call this my band templates, and I'm going to go and hook it up to a template server. I've got my little cheat sheet here just with all my IP addresses and in details here. So my little template server does live in the cloud. So I'm just going to connect to it. It's very secure. We've got a secure server key that is encoded so that I make sure that I connect to the correct thing. And also, it's a 1 server port friendly outgoing connection to that instance. So it's very friendly from a firewall rules perspective. And obviously, I can make it secure as well from a connectivity to that central server. Hit the test button here. This is going to tell me I've got a successful connection to that template server at the end of the day. Let's save it out. And what's going to happen is I will now have capability to see what is the templates that is hosted by this template server. So I'm just going to refresh my template server here. And I can see that I've got some model templates. I've also got some dashboarding or information templates that's been shared currently by this enterprise. And if I look at this, they've got a nice production template that has got a base template for an evaporator as an example. So I'm going to now, and I would like to utilize this template within my own production facility. And you'll notice that locally on a site instance, I also have the capability to create templates on the left or the right-hand side here. So what I can do is I can take this template from my template server and I can drag it across here. And this is now going to derive that template for me locally to use. A few cool things that we can do here is you'll notice that I've got the capability to map a different calendar. Now, for just a very quick overview, is the first thing that Flow does to data is it creates time buckets. It slices that data into time buckets and give the context of time as information to data so that we can use that as information. Now, at this point, my site might be running a different shift pattern. My day might start at 6 or 7 o'clock in the morning. So when I start instantiating these templates, I do have the capability to say, you know what, I've got a different pattern that I can run here. So I can select different types of calendars that I want to utilize within my production facility. So I'm going to utilize this calendar that I've already created for this line, and I'm going to derive this template. Now, deriving the template will now move the template across into my local site instance. And you'll notice that we are monitoring some temperature ranges. I want to know what's the range for the hour, the max for the hour for the temperature. I also have some aggregates to tell me, you know what, for the different states that the evaporation process is in progress, what is my kind of max and range aggregations that I want to apply to that. At this point in time, I did not care about where the data is coming from. I know this sounds weird, but for us at Flow, we create this abstraction layer of the model. Okay, for us, it's more important about what is the type of KPI that you want to monitor. Let's get that configured within the model, and then I can worry about where the data is coming from. Because the need for the information stays. It doesn't matter where the actual source or underlying piece of data is coming from. And you'll notice within my template, I've created it in such a way that I've got this kind of concept of inputs. So in order for me to derive to the information that I need to supply Flow with some inputs, right? Now, this is where we will utilize the Canary Historian from what we've created now as a time series historian, and to get connect to that data. But I could have created or connectivity to an MES database, which might be a transactional database based on SQL technology. I've got connection to my Canary Historian here. This is also pointing to the Canary that's in the cloud. And when we connect to that Canary in the cloud, look at this. We now browse the view service. So the views that Ken just created that abstracted the kind of the asset model underlying in that historian, I can now utilize that within Flow. Obviously, I also have the capability to browse to that raw view within the data source as well. So there's the DMR production kind of facility that we are going to get our live data from. So the only thing for me now to do within the Flow environment is to say, you know what? All I need to be able to do is to say, listen, where do I get this information from? Okay, so I'm going to open up this on my local instance. Notice that the retrieval section is blank here. And literally what I can now do and say, okay, you know what? This tag comes from my Canary Historian. So I'm just going to drag and drop it into there. And I can do the rest for all of them as well. So let's open all of them very quickly. I know we're running out of time, but let's just complete the process.
So that you don't rush, we're going to go over by 15 minutes.
Okay, cool.
If the audience has to drop, fair enough, but this will be recorded and posted. And next Wednesday, we're going to extend that session to 2 hours. We're going to need all 2 hours. I can already tell.
Cool. All right. So I am just configuring where the data needs to come from. And this is my product tag. So
while you do that, I'm just going to make a comment for the audience to know that you don't have to drag and drop this. If there's logic in the tag names of the data source, you could hard code that logic so that you could deploy this to multiple lines, multiple pieces.
We're coming to that, Jeff.
Perfect. Thank you, Larry.
100%. So I've created this local template, right, based on these inputs. So now you notice my template is created, but I don't have anything instantiated on my model. So my model is still blank. Okay. Now I've got two evaporators, evaporator 1 and 2. If you can look at this data structure here, some of the tags is kind of coded with a area code, and some of the tags has a kind of designator like EV001. So the tag naming convention was not standard in this case. But you just saw me dragging out all of this hard-coded into my template, which is kind of pointless, correct? Because if I want to instantiate this to my two instances, it's all going to link to the same tag within that. Now, this is exactly what we can do is by templatizing some of these parameters within my tag names. We use the concept of a model attribute, and these attributes, they weren't created by me by hand. These attributes actually came from my template as well, because we utilize these attributes in the naming convention of these instances. So they were also brought forward with that whole drag and drop, from my template server. Now what I can do is I can say, you know what, this 101, I would like to replace that with a placeholder. In this case, we're going to change that to the location code. So let's delete the 101 and just add the location code into its placeholder. I'm going to do exactly the same for the rest of them, so that we rather use the placeholder in these states. So let's look at this. I'm just going to quickly finish this off. So I'm going to go and add the location codes in there. And in this case, I can't use the same placeholder because it's different. So I'm going to utilize this equipment name rather as a placeholder for my second part of that tag holder. We've done this in the past in Integrate Live sessions, and we kind of utilized a very nice, clean tag naming convention, and everybody's asking like, okay, but what if I don't have that? How would that work? And that is what I'm trying to just show you guys here. So let's release this template. Now, if I'm happy with all the changes that I've made, I can release this into the wild, but all that means is that people can now start instantiating it to actually create a live copy of this template on the template side. So let's do that. I'm going to take this template and I'm going to drag it into my model. Now, by doing that drag and drop option, it's going to tell me, you know what, how many of these instances do I want to create? Well, I know I want to create 2 of them. And it will tell you, oh, I'm seeing that you are using these 2 type of placeholders. What do you want to do with these placeholders? Now, this is in the past where we could have created a rule to say, you know what, I want to go from 1 to 2, jump every 1, and try and address it if it is not a nice tag naming convention that I can follow. But as we can see from our tags here, there's no convention that I can follow to try and create a repeatable pattern to automatically replace those placeholders. So what I'm rather going to do is I'm going to use the capability of a CSV list or a copper separated list that I can go and populate these values to. So instead of trying to figure out a pattern, what I can rather do here is just give it the name. So I know the first one is going to be EV001, comma, EV002. So you just supply a comma separated list within here. And in this case, it's going to be 010 and a 01 or a 201 for the second line. So I can supply that comma separated list within this environment as well. Hit the preview button. What the preview button is going to do is going to just show you what is it physically going to build in the model. So there you can see it's using these values to actually go and create the 2 different layers. So if I hit the continue button, that will now physically build it within my model structure. And if I expand my model, there is my 2 templates. And if I look at my inputs here, these inputs will now, if I've done everything correct, it will now go and address the data from the historian by just replacing those little placeholders that we've got. So there we go. Notice that I'm using that location code as a placeholder. And if I look at the model attributes that's available within this template, I can see here that, oh, okay, I'm going to replace location code with 101. And that's what will give it that automatic lookup into the historian view that's been created to get that data. Again, we're using Canary as an example here, but I could have used this exact same kind of scenario with, we've got a whole bunch of connectors that we can utilize, from Microsoft SQL databases to Snowflake potentially, to even AVEVA set of historians. We can go and create that abstraction layer to extract the data and create this meaningful information from that perspective. I can go and extend that model. So if I'm switching to the actual enterprise environment, so this is my enterprise site. This is where I've created that kind of base evaporated template in the beginning. So I can go and extend this. I can create new KPIs on this model. Don't really have time for that now, but the point is I can go and create more and push that down to the site. And the site can either go and accept those changes, or they can even extend to that template on their site instance as they please. So very, very cool functionality there. Notice that I've got this capability of what we call in creating a base. So start small with the template, create base little information points that I want to measure. And I've created this base temperature, but I'm using that temperature in a more bigger piece of equipment or asset template. So we do have this capability to create these derived templates to really extend that model and to make the instantiation of these model easier, quicker, and to very quickly build out a information model that we can now deploy and have real information to monitor and make our decisions of.
Lenny, you had mentioned other historians. I know from firsthand experience, obviously with Canary and with Flow, but this is a great, I'll ask it as a question for you. Have you seen clients that are on Pi and switching to Canary use this capability to bring modeling they've done on Pi back into Flow?
Yes, so we do have some projects that's currently ongoing where we are migrating the KPIs and calculations that's been done in Pi within the Flow framework, working very closely to make sure that you just create the template in such a way that it's not a one-to-one mapping of what's done in Pi from that perspective, but just understanding the calculations and the functionality that they had, and bringing that in a flow way, so that it is now able to achieve the exact same results of what they used to have. So yes, we are busy with a few projects currently ongoing, where we are doing those conversions for them. Unfortunately, it is a little bit of a rebuild, because you have to rebuild that template. But if you've done that template correctly and rebuilt that, then the rest of the instantiation, and to now point to Canary to get the data, is a very quick and simple process.
A question came through for you, Lenny, from Keith. Do you have unit of measure conversions?
We'll probably tackle that in next week, where we're going to talk about calculations and scrubbing data and cleaning the data. So you'll notice that when I bring something into Flow, I bring it in as a tag, the raw tag layer. And just to show an example, I can take this tag here and I can drop it here into the calculator editor. So what this will do is it will create a calculated tag. Now, the calculated tag is where it will give me this kind of expression that I can go and write. So in this level here, I can do a whole bunch of fancy things. I can go and eliminate outliers. I can look at the quality code of what I'm getting back from that historian layer, the OPC quality, to determine, do I want to utilize bad quality going further in the aggregate or not? In this case, if I wanted to convert this to any kind of unit of measure, I would just done either a multiply with 1,000 to go kilo to base, or whatever the case is. So we'll utilize the calculation capability within Flow to go and create those conversions from kilograms per second to tons per hour, or whatever that conversion is. Bear in mind, very important thing, and people always knock unit of measures, but that's why it's also very important to get your unit of measures correctly configured in your historian, so that you have that capability to know what the unit of measures are. So we will go and create that with our calculated tags, to create that kind of aggregate. And if we now go and say, okay, I want to know what is the hourly kind of standard deviation, or the range or mix or max, we also have the capability within the segregate aggregation that we're now going to apply on top of the raw data to supply a scaling factor. And that's a secondary place where I can do conversions between that. And in this case, scaling factor is a pure linear conversion. If I do want to do a little bit more fancy stuff, we do have in our toolbox the capability to have functions, different functions. We do have a whole bunch of standard functions available, mean, standard deviations, etc. But if you want to go and do a real funny conversion, you can go and create your own little function that will do that for you, and you can utilize those functions within your templates and your calculations to do your conversions for you as well.
Actually, quickly before this next question, follow-up question, do you adopt the unit of measure of Canary in the presentation layer?
Yes, we do. So if the unit of measure is configured within Canary, then we will bring that forward, and the unit of measure will automatically be configured. And that's why it's important to have those unit of measures configured within Canary, 100%.
Question on templates. Can you essentially create a base template that is then inherited by another template, which is then inherited by another template?
Correct, we can. So the kind of the way, how far deep you go with that derivation is up to you. So yes, you can have multiple layers of derivation of your template, and you can even extend the template that's been inherited from the template server by adding site-specific stuff. So I might want to include a new KPI or metric on the site level, so I can go and add to that instance that's been inherited by my site, and create new KPIs for that going forward. So I can even extend that template going further and further every level down that I inherited it, 100%.
Okay, so Lenny, next week we're going to kick off with data cleansing, building calcs. This was just a preview of how to take the asset framework functionality from a information management template perspective.
Correct.
Next week we kick off with, now let's build event rules, let's add context, let's build more and more calcs based on calendar and shifts and such. So to the audience, this is just a preview, right?
Yeah, so one thing that we don't have is the context that David is scraping from the quality samples, right? So next week what we'll do is we'll extend on that. We'll extend our template. We will add the batch or the quality samples as batches that we're going to track, and add that context then to our little template here and do some fun calculations on top of that. So yeah, that we'll do all next week when we extend from this side.
Perfect. Thanks, Lenny. And to the audience, we always talk about what this costs. So as we wrap over the next 5 minutes, we're going to cover cost. And then I've got 8 or 9 questions that you've asked that are starred. We will stay on it until you are done asking questions, unless somebody on our panel has to drop, and then we'll just make up answers on their behalf. What does this thing cost? Let's do a review. David, walk us through the software toolbox pricing that we showed today, please.
So the data hub was associated with a web scraping. We're running a little script. We're pointing it to a website. We're converting that into our OPC UA server tag. So for that little single node approach, we're looking at $1,363. From a router perspective, we converted the CSV file into its OPC UA tag components. You can do so much more with router, obviously, but this is the perpetual approach. As I also mentioned earlier, there is a subscription-based approach, which is not far off from this perpetual pricing that gives you a few more capabilities. Also, single node, you can add the redundancy, the store forward functionality, etc. on top of that. So I hope that covers kind of the basic ingestion and connection capabilities that we've demonstrated today.
Thank you. Ken, can you walk us through what we saw from Canary?
Yeah, sure. So as we mentioned, of course, all our collectors co-paired with senders are free. So we license based on tag count, depending on what size of historian you're going to need. And so as Jeff threw out, hey, manufacturing, maybe we're at 60,000. We still do sell perpetual licenses, which is maybe a little different than what you're hearing from Pi and AVEVA. So for 60,000 tags, we're at $89.5 for a perpetual license, and then 18% maintenance year after year.
Okay. And if somebody needs unlimited or needs enterprise license agreements, I assume that's just a custom quote conversation.
It is, yeah. Yes, sir.
All right. And Lenny, on Flow side.
Flow side, so when we say Flow Unlimited license, what that means is we typically license the amount of measures. We don't or KPIs that we configure. We do not license the amount of connections to a Canary or a connection to whatever data source. Those are not licensed. So you literally license the instance of a Flow server. Currently 14,000 for a yearly subscription model. It's not something we host. You can still host that in your own cloud or your own private cloud or locally on site. It's still an on-site installation potentially, just with a subscription licensing model. We do offer perpetual licensing as well if that is still needed. But for a Flow Unlimited, use it to create as many information and context as you want. It's 14,000 a year from a subscription perspective.
So we had a conversation as a team. We said, hey, let's look at cost of ownership. Realistically, to deploy and manage these solutions for most operations, it's a staff of 1, maybe 2 people. Implementation times are going to vary depending on the scope. This could very much be a very fast implementation of the software toolbox tools. On the Canary side, specifically with MQTT logging or OPC UA path-based logging, it could be a 30-minute setup to be logging everything. Depending on what type of asset models you want to build inside of Canary will lengthen the time of deployment. Flow software could be a couple weeks, could be a couple months. Again, just depends on the scope of the use cases around what you're going to see next week when it comes to those KPIs and those models and events and the data flows. But implementation time will vary. It could be very short. It could be a couple of weeks. It could be a full year project. But take a look at the year 1, year 2, year 3 cost based on what we're showing today, and really almost identical next week. There's just a little bit of license change next week. You're looking at about $100,000 year 1, and then a $30,000 renewal or recurring cost for subscriptions or for maintenance. Maintenance is already calculated, everybody, in those year 2, year 3 figures. That's what we mean when we say fair licensing model. And with that, I think unless the panel has anything to add, let's move to questions. Good?
Good.
Okay. I'm going to go in order they came in based on what I've got starred. So if I miss you, please come back and repost that question. Luke has a question for you, David.
Yes, and that's an interesting question, and I'd like to probably not answer that now. There are some development happening in that environment, but it's probably going to take a little bit deeper discussion. So, Luke, I'm going to ask, please reach out to me. My email address was tagged, and I'd happily have a discussion with you further about that.
Okay, thank you. Coming back down the list, Lee has a question for you, Ken.
No, not at this time. We are a purpose-built time series, traditional data. So, storing structured data or, classes of data is not a good use of our storage mechanism. Can you do it? Yes. Can you utilize any of our tools to pull that back out and understand it? You're basically limited to the API, so we do have blob storage. You can, throw in whatever you want, but it's not going to be very useful within Canary other than simply being a data store for it. And it's a pretty inefficient storage at that point.
And still for you, Ken?
No. In order for Canary to access the data, it's got to be, either a local drive or a UNC path. I don't believe that you could directly attach it to the S3 cooled storage. I just don't think that's going to be possible.
Okay. Ken, you're on the hot seat. Lots of questions were coming in, which is great. If you were in sales, that would be a good judge of interest. Continuing on, talk about the leading tags, please.
Yeah, so we are a historian. We don't like to get rid of things once we've recorded them. And so tag obsolescence is the solution to drop tags from the historian and from views. And right now, that obsolescence process can only be done through certain collectors or through an administrator function within the Canary admin.
Okay, thank you. Keith made a great comment. I don't want to shy away from it. He had I think Keith said, hey, Jeff, you misspoke here. With Asset Framework, you do not need to import the SQL data. You can just link to the source and use the data as required. Thanks, Keith.
That is correct, yeah.
Here's the caveat though, right? Like I have to, that's how I'm building my information model. If I'm building it on top of Pi, I have to have Pi everywhere. I can't combine that effort, right? I'm going to have to add more Pi tags, not for the SQL data, but for any historization that I need to do. Let's take the next one. Template inheritance. What about static data? Okay, so this was when Ken was demonstrating Canary. Was there any equivalent functionality to support template inheritance? What about static data, i.e. constants that may be used in calculated tags, or is this going to be handled in Flow? I think the strategy that we're showing is that this is handled in Flow. I do want to not miss though. Canary has calculations. Canary has events. There's things that you absolutely can and should do in Canary from a strategy around information management that might very well have you flagging events in Canary, building calculations in Canary. Specifically, I'm thinking, Ken, of running calcs. So if I've got a temp tag and I want to know what's the 5-minute average running temp. Every time that temperature value changes, it's going to give me the new average for the running 5 minutes. Or I might have a group of compressors, and I want to know what is the maximum value of the group of compressors, or what is my count of compressors? I've got tanks. What's my total volume, or total volume based on all of my tanks? So there's a lot of strategy around information management. It's not just a copy paste architecture. And this is where having a great integrator partner or having a conversation with people from Canary and Flow, they are going to advise you on what to do where and when and why. Good question. JC would like to know the group's thoughts around using a UNS for contextualizing the data instead of using one-to-one connections to data sources. David, do you want to take this?
Not really, but
Okay, you don't have to.
I mean, yeah, I think you're the better guy. I've got my opinions about that, and yeah, it's a yes and a no for that matter. First, you got to get to the data, use the right tool.
Okay, David actually invented a new acronym the other day while we were on a session, and I thought it was appropriate for Dad Joke Central Integrate Live. David, what was the acronym that you created around a new version of the UNS?
So we used all my data from Data Hub and from OPC Router, and we put it in one namespace, and I refer to it as a UNS. And then you were cleverly saying, no, that's a polled UNS. And then you came up with the concept of it's a puns. And yeah, that shows the nerds in all of us. Eh?
That's right. That's right. So to maybe talk just a little bit around this concept of using the UNS for context. Absolutely, right? You're going to get context from many different things inside of an information management system. The UNS is going to provide you context. It's going to provide you structure. It's going to provide you whatever it is that you're able to attach to that data at the edge, which is typically where that data is entering your UNS. It's not going to give you all of your context. And the idea is to try to eliminate, as JC pointed out, one-to-one connections to data sources. Maybe next week, we'll start out with an architecture showing what we internally inside of the Integrate Live community have referred to as a unified analytics framework. And that essentially is pulling context from the UNS. It's also pulling context from the information model, so that you are really only maintaining 2 points wherever possible for that context. And you're treating the UNS as a hub. You're treating your information model as a hub. In this case, Flow is serving as that information model. And you're grabbing the context from everything connected to those 2 hubs. JC will lead with that slide next Wednesday.
If I could just add to that a little bit too, what we see is, for greenfield projects, UNS has really good adoption, and is really powerful. For brownfield, it's sometimes expensive and painful to go back and kind of retrofit or do all that definition out at edge. And so we see less of that, in existing operations, and they tend to handle that more on the backside, whether that's with us or with Flow.
Yeah, you need something that can connect to the data, right? Because you have all the legacy equipment in 3. That's where, for me, that's where Data Hub becomes very valuable, or, where I can now have all the different tool sets to connect to all kinds of different, whether it's OPC DA, UA, whether it's, I'm using the software toolbox, what's it called? It's not Kep Server, the
Top server.
Top server. Whether I'm using Top server along with Data Hub, well, now I have all those legacy drivers. Then you'd add in OPC router. Now I've got a full toolbox of opportunity to connect directly to those end devices or the PLCs directly. And now I can convert any of those protocols to MQTT. Now I'm publishing to a broker, and now I'm not going from the PLC to the HMI to the historian, and then changing names every time. I'm connecting it as close to the source as I can, converting that to my UNS, and getting it into my broker.
That's
All
well
right.
said.
Thanks, Alan. Lenny, question in for you. Is there an API or SDK available to perform these operations programmatically in Flow instead of dragging and dropping and building your model that way?
Currently, we do have an API, and the API in its current form is to read out of the Flow model. So unfortunately, that's what you've already built. But I can say we are in the pipeline in our development cycle to have a config API, which will allow you to perform these operations programmatically. But that's still in development. So currently, the API is limited to reading, not writing as yet. I will keep you guys posted on when that functionality will be available.
Planned ETA?
Putting me on the spot, but that would probably, how this software release cycles go. February of 2020. No, I'm just joking. That will probably be Q3 this year. We will have something available.
Good. Fall 2024. Lenny made a promise. You all can hold him accountable for that. Lenny, don't ever give a date. Come on now.
Q3. I don't know, but yeah.
September 1st, says Lenny. Thank you, Lenny.
No.
Another question. This was in a follow-up to the templates of templates of templates. But can you combine multiple base templates into a higher template form?
Yes, you can. We are also in the process of releasing what we call relative calculations that will be able to relatively go and do calculations based on the amount of turbines and stuff that you do instantiate. But yes, you can create then a big combined template to represent a turbine in this case. That's going to have all your pieces of equipment and your bearings across that.
Perfect. Thank you. Dawood, can you talk about the plugins, please?
Right. So I've got a list here. I'm going to sound like one of these pharmaceutical advertisements on television. So, no, might kill yourself. But the reality is, so just to put it in very context, whether I go perpetual, whether I go subscription, there's always a base component. The base component contains all the base plugins, which I included. So that's a calculator, that's the XML, that's JSON, that's CSV, that's time triggers, variables, constants, text replace, local file transfers. Then from there, you branch out saying, look, if I only want OPC UA, after that, you just license an OPC UA plugin and you go the perpetual route. If you'd like more, you go to the standard subscription route, which includes all your databases, excluding SAP, but all the Access, SQL, Mongo, you name it, Excel, MQTT, UA Classic, UA Server, UA PubSub, REST API, Sparkplug, Telegram, etc., etc. So again, I would say I don't reach out to me if there's a specific requirement, but because you've got to decide which way you go in terms of which plugins are included.
Okay. Keith's question, thank you, David. Does year 2 and 3 numbers include Canary Lab maintenance fees and Software Toolbox maintenance fees? All maintenance fees are included in years 2 and 3. That's where this solution stack starts to get really advantageous. I'm sure if you compare some of the maintenance fees you're already experiencing on some of those Pi solutions, you're going to see right there's your ROI. Probably faster than a 3-year ROI. Keith says, hey, I missed the first half hour. Has this been recorded? And so how do we access? Yes. YouTube, Integrate Live channel. You'll find us, just search on YouTube for Integrate Live. It'll be right there for you. Nate wants to know, will the next session go beyond data collection and visualization, include scenarios of how problems can be solved or maybe even predicted? Nate, let's do that. We will cover those types of use cases in the next session, keeping in mind that on the next session, not only are we going to be talking about how we're building calculations, how we're doing projections or predictions, as some will call them, of those calculations, but then how are we going to share that information? Because look, this cannot ever be a locked down black box type solution, has to come out. So how do we demonstrate getting it out to other applications, maybe cloud? How do we show this information via an OPC UA server using one of David's tools? How do we put it on dashboards? How do we expose all of this information to client APIs? All coming next week as we round this out. Just a reminder, that means next week, 2-hour session, we're going to cover calculations, cleansing, contextualization, aggregations, dashboards, reports, automated data streams, and the API. I'm already tired just thinking about it. Guys, I think we're going to need at least one planning session before we go live. And to the audience, I hope you understand that when we do these, minimum work as far as planning for this upfront. We rely on the men and women that are the experts from the vendors, Ken, Dawood, Lenny, to bring their A game. They know how to use these tools. They're demonstrating them and building them out as much as they can in our shorter time frame in a live standpoint. So all in 2 hours, Nate says, good luck. Thank you. We're going to need it. Alan, you're always the guy to end with a dad joke. So let's get the first well-scripted ending of an Integrate Live session ever. I'm going to thank our panelists, and then Alan closes in a dad joke. Lenny, Dawood, Ken, thank you so much. From the attendance, from the questions, I think this is a current subject of interest. I know that there's a ton of people talking about how to build these solutions, and you guys have really done a great job of showing us the building blocks behind that. I cannot thank you enough.
So I've been starting to learn German, and I was surprised to find out the word for constipation is Pfarrverpuppen.
And that is another Integrate Live session in the books. To our community, thank you for putting up with us. Thank you for your continued support. Please email our panelists, let them know any other questions that you have, and we will see you, assuming that you remember to register, next time. Thank you so much.